Industrial process heat accounts for almost a fifth of global greenhouse gas emissions annually, or about the same as the combined greenhouse gas emissions of the US and India, two of the top three emitters in the world. In homes and offices, we use heat pumps as a more sustainable source of heat, but they're not appropriate for industrial processes. They require temperatures often up in the hundreds of degrees Celsius, up beyond 1,000 degrees sometimes. Today, most of that heat is still produced by burning fossil fuels, more often than not natural gas, accounting for roughly a quarter to a third of total energy use in manufacturing. But there is a better way. High temperature modular heat batteries, sometimes called thermal energy storage, offers a scalable electrified alternative to fossil fueled process heat. By using cheaper off peak or otherwise curtailed renewable electricity as a source for heat and delivering it on demand, thermal batteries can decarbonize industrial processes without compromising reliability or performance. It's not just an incremental improvement, it's a fundamental shift in how industry produces heat. Today, I'm delighted to be joined by Paul Keane, who is founder and CEO of Re-Therm Sustainability Limited. They're a startup which manufactures and installs modular thermal batteries, all neatly packaged up inside a standard shipping container. And this approach makes transport and installation a lot easier, often taking up as little as a car parking space in a customer's premises. And like a traditional battery, these modular units can be combined to suit the thermal demands of their customers. I really hope you enjoyed this video, and please do like and subscribe if you do. I mean, most people, when they think about energy storage, they're thinking about your traditional battery, with its chemicals and all the rest, and it's storing electricity, basically. Um, but you're doing it completely differently. You're storing heat, is that right?
Yeah, so to get cheap energy, you need to store it. You can't be using energy. The reason it's cheap is because it's in an off-peak period. It's a period where there's very, very low demand for electricity, which is at nighttime. So to get that electricity and load shift it to use that load of electricity during the day, you have to store it in some way. And to store electricity in electrical batteries is expensive. The batteries are expensive. The siting of them is difficult, and it doesn't really make sense for heat use.
Mhm.
So thermal storage is a far less complex method of storage. You're just really heating up rocks. If you remember the old storage heaters I don't know if they're still around, but like in
I
apartment
do indeed.
buildings, it's just a
Yeah.
block in a. No, they were terrible. They're horribly inefficient, but our system looks to improve that, bringing the efficiencies well above 90%, probably up around 95, 96% efficiency during a 24-hour cycle. So we're just basically taking that electricity at nighttime. We're converting it to heat to very, very high temperatures. So we can store up to 1,200, 1,300 degrees C.
Wow. Okay.
And then using that as your primary heat source. So instead of burning something, the next day you have this 5, 10 megawatt battery sitting there, and it can be mixed in any way for any temperature. So it's a very versatile, and it's very simple in comparison to electrical storage.
Wow. And I mean, what are you heating up? I've heard of things like salt batteries where you heat up salt to where it's molten and so on, for kind of big solar farms where it's all concentrated down in one spot and you melt your salt, et cetera, et cetera. But I'm not too familiar with then what else is in that space.
Yeah, salt is cool. I like all the energy storage side of it. It's fascinating to me. So I do look at all the technologies. Our first technology is a sensible storage medium. That's what it's known as, and that just basically means it's a solid state medium. So it's rock.
Okay.
Essentially, we're using rock. We're using a complicated rock, but it is you could actually do the same thing at less efficiencies with a pile of limestone, or a pile of granite would probably be better. But so it really we're heating up this rock, and the core of this volume stays hot due to the system that's surrounding it. So it's heated by air. The air passes through a resistance heater, just like the little heater you'd have under your desk, maybe to warm your feet in the winter. Except it's maybe about 1,000 times bigger. and that heats up the rock, and then that will stay hot for 2, 3 days very, very efficiently.
And your hot rocks inside a container, then what do they heat typically?
We've already have about 11 or 12 projects where we've done software prototyping, we've done CFD modeling, where we're looking at industrial scale heat. So one would be a metal manufacturer, so they would produce parts, basically very high grade components for the aviation industry, for the likes of Amazon and Google data centers. And they have these flow ovens or conveyor belt ovens where parts are going
Yeah.
through this oven and the oven needs to stay at a certain heat. So they usually heat that with LPG, and with our product, you just bypass the LPG and you're heating it with this hot mess.
Okay. And is there much involved in kind of plumbing your solution in? The containers arrive outside the building, I presume. Do they stay there and then they get plumbed in somehow to uh,
Yeah, it's site specific. So
okay.
like we're looking at a number of hospitals as well. So their plumbing is a little bit different because you're looking to plumb into hot water.
Okay.
But really the unit itself, when you have you'll have just basically manifolds ready for the system. So this is basic plumbing. It's not anything complex. Basic industrial plumbing. That system will arrive and hook up and be ready to take energy by the end of that day. So
Yeah.
it's a very, very quick turnaround because you're really just plugging in a heater or plugging in a boiler system. It's the same.
Yeah.
There's no new requirement for knowledge on that side. It's fairly straightforward.
And I mean, do you design a solution for each use case, or is this in some way modular, or can you put them all together?
Yeah, so each use case has different thermal properties.
Mhm.
So there is tweaks and
Yeah.
that you would have to make. But generally speaking, they're generic. They're a generic system, and you can like one of the pilots that we're looking at will put in. They have about an 11 megawatt requirement in
Mhm.
total per day. So at peak. So what we'll do is we'll put in probably a 4 or a 5 megawatt. We're just working on that right now, and then they will upgrade. So that there'll be a manifold ready to plug the second one in. The second one
Okay.
is easier to plug in than the first one because all the infrastructure is already there. And the second unit will be like a slave unit. So it'll the first unit will have all the smarts. Second unit will just be extra storage.
Yeah. Oh, with those temperatures inside these containers, I presume this is pretty safe and proven technology.
That's what took me the longest to get my head around is that you have 1200 degrees Celsius right there. But there's a bit of magic sauce that goes on. The 1200 degrees Celsius as well is not the whole box. It's the core temperature. So there is temperature gradients that work out from that, and then you have an insulated layer. So you can actually lean up against this box. It'll be slightly warm than the ambient around it, not that much because we don't want it losing heat,
Yeah.
but it'll just be very, very slightly warmer. So you won't think that like less than a meter away from you there's a 1200 degree core.
Is there something you would say is fairly unique about the way you're delivering this solution, be it on the technology or the way it's being delivered?
This will work for 20 years. The system, you'll never need to open the doors of this system. That will
Right.
just, once the doors are closed, it's ready to go and it'll work for over 20 years. The storage medium itself, the storage medium doesn't degrade. It's a heavily carbonized type of rock, so it'll just sit there, heat up and cool down, heat up and cool down. So just by its own internal infrastructure, it doesn't degrade at all.
Mhm.
So and the parts are very generic. So you don't have to go to China to go get another part. This is going to be manufactured here. The fans
Right.
will be sourced within Europe. The actual material is used. 90% of the mass of the total unit will be made of recycled materials. The storage medium itself is waste material. We'd be looking to use secondhand shipping containers because
Yeah.
structurally they're sound for a long, long time, longer than we need them. So it has a lot of benefits in that way. but it does exactly what it says in the tin.
Yeah. Would the customer typically buy this up front, or do they lease it, or how does that work?
It is an expensive thing to build, and it's a very valuable long-term asset. So when you look at it from that perspective, you can leverage this where the client doesn't have a huge upfront cost, and you can just be their utility. So you can provide heat as a service to them, where
Okay.
you're just really charging per kilowatt hour of thermal energy that you're giving them. And when you expand that, when you look at maybe 50 installations on the same grid, uh, you now have larger buying power, and you can offer these lower and lower prices as it goes on. And because of the longevity of the system, you can offer this heat as a service for a very extended period of time, and you have very obvious maintenance costs, like the lifetime of there's big blower fans, and the resistance heater will have a typical period where they need to be changed out. The customer doesn't have to worry about that. It'll just be all part of the utility.
That's like a no-brainer for anyone who's spending so much on heating whatever process they're running.
It also it can integrate with machinery. Like say, if an oven is using LPG, they're usually just in the LPG is really being burnt in a burner box, and all we're doing is plumbing into that same box. So you don't have to completely overhaul the equipment. You can just add this as like a second boiler. That's really what it would look like. And we can also integrate with the control systems that we're feeding. So
Mhm.
so it's very minimalist. You just have to have the space for it, and that sometimes can take a because space is a premium in any industry. So, but we can go above it, below it, beside it, outside, inside. It takes up a car parking space, so
Yeah.
it's very versatile, and you can just run a hot pipe to wherever you need it.
Oh, very good. In terms of the future, then, what do you see as next steps for you guys? Is it about scaling the whole thing up, or is it scaling it out geographically? A bit of both.
So our startup goal is 100,000 tons of carbon displaced. So for every kilowatt thermal of heat we use, we're displacing about a fifth of a kilogram of carbon. So that's really our goal. Everything has to get to this 100,000 kilowatts and to or sorry, 100,000 tons of carbon. But as we're um, as we're growing out, our real key asset outside of the technology is actually the manufacturing process. Because anybody can build one, it's building 1,000 is very, very difficult.
Yeah.
So we had the plans for that pretty earlier on, and we're refining how to actually make these modules a lot quicker. And that's something that's unique globally at this efficiency level that hasn't been really done. Bryn Miller are close, Rondo are close, but they're using a different technology for a larger energy use. But in our scale of things, really, it's the manufacturing. And we haven't released this really yet, but our 5-year goal, once we get to that 100,000 tons, we'll be looking at 1 million tons for 5 years.
Wow.
That's how we would scale that, and it's kind of logarithmic because all these units are already decarbonizing as we move along.
So it's great to hear that an indigenous company is doing this type of stuff.
Outsourcing this isn't an option. It isn't an option because it's a very heavy product. Shipping this across the world would be daft.
Yeah.
So creating local skills, both in operations and in manufacturing, but also on the research side. Thermal energy storage is in its infancy. It's like where wind was in the mid 90s. There's a lot of work to be done. So there's a lot of there's a holistic approach to this from research all the way to sales, manufacturing. I want that all to be based here.
Yeah. Brilliant, brilliant. So Paul, I thank you so much for your time today, and I
Thank you,
think
Francis.
we'll all be keeping a very close eye on Re-Therm and what you're doing in the next few years, and the best of luck with that.
Thanks very much.